Hi, everyone. Welcome to the Azure Takeoff show. Today, we have a very special guest, Özgür, with us. Özgür, do you want to introduce yourself?
Um, Hi, everyone. I'm a digital native solutions architect at Microsoft. So, typical digital natives, I cover the whole technology stack, trying to focus on machine learning and data with my customers. I've been on this role working with startups and digital natives for the last 5 years, and have helped quite a few startups in Turkey and across the region through their journeys, and a couple of them becoming unicorns throughout my experience with working with them. So thank you.
Great, Özgür. So today, I think you have a little bit of a background of machine learning, and you're really interested, keen on like OpenAI and all that stuff. So why don't we talk about I know that you wanted to explain the understandings of OpenAI. So do you want to share your screen?
Sure. Thinking about OpenAI, it's such a practical service for our customers to use. I think sometimes we miss the larger context and how we've come this far, and I think this will affect the way the service itself is perceived and the capabilities of it. Uh, I'm sharing my screen, so that's okay.
Mhm.
So I wanted to give a larger view on the significance of this technology and start with generative intelligence first, what it entails. So generative intelligence is something that is inherent to human intelligence, because that's the way our brain works. The human brain tries to predict the potential inputs that it will receive at any point in time. So we are making thousands of predictions every day. And that was very important in an environment that was dangerous as well as fast changing. And the way the human brain does this is throughout the models that are embedded into the neocortex of the brain. And models is quite a central concept for generative intelligence as well as generative AI. We can define a model as being simplified and condensed representations of reality. And once this model is created, we can then create copies of the reality. And the better these models are, the better the outputs will be. And this is the same for generative AI. In generative AI, we use probabilistic models. And actually, there are now some theories around brain itself being probabilistic. So this is called Bayesian brain theory. And what we do is, given a data set, we create the models for the data set, and then we sample the data set. And the outcome is a representative of the original real asset. And then we create a copy of it, hoping that it is similar to the original. So this is generative intelligence.
Okay.
Oh,
So I
yeah.
have a question. So what is basically then generative AI then? If we learn about generative intelligence
Mhm.
as a brain sort of thing, but what's generative AI then?
What is interesting with generative AI is we move from classical ML to a stochastic place,
Mhm.
where we no longer work with the variables themselves, but with their probability distributions. Uh, and and again, we try to learn patterns and structures
Okay.
uh, in the data that we're given. We create the model uh, through machine learning training, again, neural networks, and then we use these models to sample the data. So we try to come up with an actual representation of the original data. And the better our model is, the representation will be highly accurate and it will resemble the real original data set. Uh, and that way, we're moving from discriminative machine learning, which is the essence of classical machine learning, which does uh, classification, regression. We try to predict decision boundaries. That's why it's called discriminative. To
Mhm.
the generative domain, which is mostly about entropy, and
Okay.
the stochastic and probabilistic representations of the variables themselves. Uh, and this is a field that was launched much earlier than the GPTs of today.
Okay.
Uh, and like in 1970s, we have variational encoders. Uh, and again, the way we do this is we impose constraints so that the
Okay.
learning is denser, it's lower dimensional. And the way this is done is by putting a smaller neural network between two large neural networks.
Okay.
And then we do representational learning, we do the latent space, lower dimensional space, and then we move up again by the model that we've learned. GANs is quite popular. We all know what deepfakes are, and deepfakes are generated with generative adversarial networks.
Okay.
The way this is done is there are two different neural networks, and the adversarial part actually administers the generative neural network, and they try to shape a random noise through something that resembles the real asset that we are trying to recreate,
Okay.
which the adversarial part of the network knows.
So I
Uh,
have a question. So in some ways, it's like if I see a deep fake video, the person's face, Tom Cruise or whatever, that who's not playing in the movie sort of thing, but they put the face in, they're using actually GANs to actually do
yes,
this.
definitely. So they are using the GAN. So you know, uh, we all we now have representations of all the mimics, all the movements. So what we do
Mm,
is we just impose them on the original data. So if you want to have Tom Cruise smiling, you just
mm.
add this extra data into the model so that it looks like it's smiling, and you do that consecutively for every gesture, mimic, and movement, and then
So,
you have deepfake.
so I also see transformers. What are transformers over here?
Yeah, so I wanted to talk about transformers too, because GPT OpenAI itself is
Mm,
based on transform models. Transform models are revolutionary in the sense that they actually uh, made the field move like light years ahead in
okay.
2017
Mm,
when transformer architecture was released by Google, actually. And uh, and if you go back to the again history of this, we have the NLP domain, natural language
mm,
processing, which actually tries to come up with language use cases, translation, text generation type of use cases. And the way this is done was with RNNs and special neural networks called recurrent neural networks, LSTMs, GRUs. But they all
mm,
had their own constraints. Uh, because what's special with this use case is uh, speech itself is sequential, and usually with text generation what you want to do is you want to predict the next word in a sentence. So
mm.
these models are called autoregressive models because they predict n plus 1,
Okay.
like a time series. uh, and the research, the field, what after years of experience, what we learned was uh, it's not only important to understand each individual element in the sequence, we also need to understand all these correlations and relations between
Mm,
word, syllables, and even the grammar.
yeah.
And transformers actually help us do that better and in a larger range,
Mm,
which we today call context in GPT terminology.
cool.
Yeah, so this is uh, the benefit transformers bring to the NLP use cases.
So that was good. What do you think, Chat GPT? Why does it work better? What's the OpenAI secret sauce, basically?
Yeah, so if you go back and read through, or there are also videos on this, like the OpenAI scientists, like Ilya, Sam Altman himself, the journey that they went through. One think comes across quite frequently, that they bet on scale. So from day one, the OpenAI team believed that the larger and deeper a neural network is, the better it will be able to address complex and more sophisticated use cases. So that was the first bet. And if you look at GPT-4
Mm-hmm.
today, we don't really know the actual number of parameters the model has, but it's second to none in the industry. It's the biggest model. And yeah, that was the first bet. Second one was reinforcement learning. And again, I think the team, OpenAI team, it seems, was believing that there was huge potential in reinforcement learning, and they started working on it. They, I think, late 2010s, they released a model which was playing a very competitive real-time strategy game called Dota 2,
Mm-hmm.
better than human players. And the way it was doing that was with reinforcement learning, which means an agent actually learning through transacting with an environment. So by repetitive failing and by functions, reward and penalty functions, you can have an agent behave as the way you want. And we're all familiar with this with like computer players beating Go, machine learning models playing chess type of use cases and games. And the third one was data-centric AI. Again, we don't really have the full details, but we know that there is some special procurement of the data so that it becomes better suited to the GPT model that OpenAI team is training. So these three, I think, can be attributed to the success of GPT model.
Okay. So, what do you think it's the secret sauce by scaling? Basically, in some ways, it's like this.
Up to now, it was scaling, so it's a bit controversial now because if you look at the latest interviews of the OpenAI team, it seems the team will go deeper into trying to understand the emergent capabilities of the model itself rather than start trying a larger model. But up to
Okay.
now, it served them well. And if you look at the open source space, there are also some claims that smaller models are quite performant as well with new and innovative training techniques like LoRa, where again they try to simplify large models and train them with OpenAI inputs, which is called distillation. So yeah, this is an active research field. But GPT-4 itself is a large model, and it seems it worked for the OpenAI team.
Okay. So, what do you think is the Azure's OpenAI, the Azure offering of OpenAI? What are its benefits and what's the differentiation? I know that there are other companies that are claiming OpenAI and all that. I know OpenAI is an umbrella sort of thing, like for OpenAI, but like I mean, there are other companies that are starting to offer some. They're offering. What is the main differentiation and what's Azure OpenAI benefits?
Mhm. I think it's largely acknowledged that GPT model itself is the best model, best
Mm,
large language model or foundational model uh, that is available right now to the public. There are many reasons to that. I just mentioned, and there are also barriers like financial barriers to be able to train such a large model, to use uh, human feedback to train and fine tune the model. Uh, but the largest benefit, I think, in Azure OpenAI which is actually the model itself being moved into Azure and wrapped
mm,
around an API, is the capabilities that it gives digital native customers or any customer, in all due fact, to be able to build uh, and leverage the deeper and wider platform of Azure. So you can basically integrate everything, integrate all the services that Azure offers you. You can put some Azure functions which does the GPT calls. You can keep your API keys for Azure OpenAI in Key Vault. Uh, Use Cosmos DB to store the unstructured data that you get from your prompts. So there are many use cases, and there are no limits as to what you can build and how innovative you can be.
Okay. Do you want
And also the second largest benefit before we move on
to?
is the bias reduction
Mhm,
technology, and the filters that are implemented to avoid offensive or hazardous content.
mhm,
These models tend to hallucinate as well. So there's usually a parameter called temperature,
okay.
and the higher the temperature, the closer it is to one, uh, the more random and creative responses you get from GPT, and that sometimes tend to cause problems because there are already some implicit or explicit biases embedded into the model itself because the data has them. GPT is trained with all uh, most of the human generated digital data,
Mhm,
which includes our biases in them. And yeah, we put controls in them so that they became more aligned. So human alignment is a big area of research as well.
mhm.
So it becomes more suitable for enterprises, for any company that is bounded by regulations to their customers. It's a safer uh, variant of the model itself.
That's good. You talked about OpenAI and enterprises company and stuff, but what about startups? How it got help with OpenAI, with Azure OpenAI?
Sure. I think Azure OpenAI has huge potential to accelerate startups through the capabilities I'll just mention now. So first of all, startups are learning organizations, and the way they learn is through faster prototyping and faster MVPs.
Mhm,
So you need to go out to the market with your MVP to get feedback from your small loyal set of customers, modify or pivot and keep learning that way. So strategic speed is the first impact I think startups will see leveraging Azure OpenAI. And GPT-4, the main capability that will help with this is GPT-4's code generation capabilities.
mhm,
Uh, there are now two different set of capabilities embedded into Azure OpenAI as well as into GitHub Copilot. The way Azure OpenAI uh, helps with code generation is it can create skeleton code for any
mhm,
MVP in any framework for any developer. So it's not really like GitHub Copilot, which tends to accelerate developers, increase developer velocity, productivity type of thing. You can just write down a good prompt with your idea, ask ChatGPT or OpenAI APIs to come up with the code that will result in the application. And I was actually able to create a polyglot application, React
mhm.
front end, a fast API, Python backend, uh, in like 2 hours by this by actually feeding back an error message that I got back to OpenAI and getting responses and correcting my code. So you don't even need to learn or know. So that's the extreme, but it speeds up significantly. It leverages you with superpowers in that sense, which I think is quite exciting. Uh, and secondly, it can help with many of the non-core services like marketing, personalization. You can
Mhm,
create recommendation engines, for example, for your products with OpenAI. Uh, I have a blog post on this. You can, so you have a catalog of products, for example. What you can do is there is an OpenAI, Azure OpenAI API called embeddings. You can
mhm.
extract product descriptions, product names with these embeddings, store them in a vector database, and by using previous interaction data from a customer, you can come up with a collaborative filter which can offer similar items to the customers.
Okay.
You can do sentiment analysis. You can offload your social media management. Uh, so the use cases are endless, and your creativity is the limit here.
Okay.
Uh,
Now,
yeah,
now we talked about a bit about startup sort of thing. What about gaming? Like, I mean, what do you think
sure.
OpenAI is going to help with gaming? Like, what are the use cases that we see?
Gaming is, the potential for impact for OpenAI in gaming is quite exciting. You can basically create worlds with Azure OpenAI.
Mhm.
Uh, so what we expect is all the content, the value of content, actually going asymptotically to zero in time. This is again a bit ambitious, but if you look at the way this generative technologies, the speed these technologies are developing with, you can basically generate uh, all the assets, creative assets of a game by just using generative technologies, like
Mhm.
the name of the game, start with name of the game, the plot of the game, the characters, the character histories, and another thing that we expect to happen is right now we have like static progression of games, but then with the generative technologies, since you have a magic tool to be more creative, gameplay experience will adapt and change as per gamer histories and the actions each
Mhm.
gamer has throughout the game. Secondly, NPCs or game characters, you can associate. There are some demos on this as well. Like with Unity, you can associate a character that you created
Mhm.
with an OpenAI agent, so that he can take on a persona that you assign to him with a prompt, and uh, start interacting by staying in that role throughout the game. And it's that way we expect the NPCs, non-playable characters in the game, to be playable. So all the characters in the games will be playable.
Oh, okay, that's pretty
Uh,
cool.
so yeah, the possibilities are endless here.
Mhm.
Another thing is, generative technologies. What the industry thinks is we are quite at the early stages, and right now they will help accelerate the tooling side of things. So
Mhm.
if you're using Unity, Unreal Engine, or Blender, there are interfaces already where you can use these tools with LLM prompts, like prompts created by OpenAI. You can
Mhm.
integrate these to your game pipelines basically, and going forward, the effect will be more transformative. So the generative technologies themselves will be integrated into the game engines. So yeah, it's a quite an interesting and exciting area
Yeah,
with lots of possibilities with gaming.
yeah, I could totally see that too. So, what would be your call for actions going forward?
Uh, so yeah, with all these possibilities, I don't think anyone can afford being outside of doing anything in this area. So joking
Mhm.
aside, we advise our customers to start playing around with creating or building on OpenAI, Azure OpenAI technologies.
Mhm.
And we already have, like for startups at least, we have credits through Startup Founders Hub,
Mhm.
where they can start experimenting with zero cost. And secondly, there are also open source
Mhm.
technologies and open source alternatives. And I think it will benefit to everyone in this area or planning to build products in this area to understand the capabilities or limitations of these models as well. Uh, and I think this creates the contrast for Azure OpenAI's capabilities for one to appreciate these sort of advanced capabilities coming with Azure OpenAI. Uh, Secondly, you can already start being leaner by these automation capabilities I just mentioned through
Mhm.
GPT plugins or automation through development frameworks through like LangChain, and we now have semantic kernel that's developing. So the development barrier will also come down. So it's like
Okay,
all the barriers are coming down. So there is no reason to not be curious and creative with Azure OpenAI.
great. So, thank you so much, Oscar. Like, I learned quite a bit of understanding OpenAI today, like all the stuff. Hopefully, I'll have you again on the next show. Maybe you could go more, a little bit more deep dive into each of these individual subjects and stuff.
Sure. Thank you very much,
Mhm.
Taswar. Thanks for having me.
Yeah. Thank you, Oscar. See you.
Thank
Bye.
you. Take care.